Hi, everyone. Happy to have you on our weekly Wednesday Wisdom session. We're going to wait a few more moments for everyone to join, and we'll start. All right, everyone. Happy to host you here on our Wednesday Wisdom session. I'm Eyal Golombek. I'm the Director of Product Management here at DAS, and today we're going to talk about a very interesting topic that's very dear and near to my heart, which is the root cause remediation and how to get to the root. We're going to wait a few more moments for everyone to join, and we'll start diving deep into the root causes. All right, I think we can start. So once again, everyone, I'm Eyal Golombek. I'm the Director of Product Management here at DAS. And today you're joining one of our Wednesday Wisdom sessions where we're going to talk about how to get to the root and find a better way to triage and fix cloud security issues. This is a very interesting and topic that's very near to my heart. So hopefully you'd find that also enlightening. So let's get going. All right. So I think, first of all, we need to understand the security and the cloud security space today. And I think the first thing we see is that the situation that security teams have to deal with today is just way too complex. And there's so many inputs and so many data points and so many noise that security teams deal with on a daily basis. Just as you can see here, very few examples. At first, there's just so much risk in the environment. There's so many alerts, so many issues, so many tools that work on detecting those alerts and issues. And you can see that everything is critical. Everything is always super risky. It's so hard to prioritize, so hard to understand what we should address first. And those numbers are just one example of real life environments where we have, in this case, 80,000 critical issues. So when you have so many critical issues, how can you actually address what is critical? Everything is alerting us on more and more noise. You can see here an example of 700,000 open issues. That's, of course, a huge amount of risk, huge amount of alerts. But the question is, does it all alert on actual risk, on actual problems that we need to fix? And of course, security teams have a lot of policies that they want to make sure they meet at the end of the day, whether it's SLAs, whether it's mean time to remediate and other business-wide policies. And of course, it's very hard for security teams to make sure those policies are actually met. And usually alerts go over past their SLA, even critical ones don't get remediated in time. And of course, this exposes the organizations for more risk for longer, which increases the probability of a breach, which is, of course, not what we want. And on this slide as well, you can see on the left-hand side the amount of different detection tools that are out there today, all doing a wonderful job at detecting different risks in our environment. However, a normal security team today would have to deal with 5, 6, 7, even 10 different detection tools for just one area of their environment. And it's so hard to keep track of this huge amount of data and this large and this very big complexity of the environment. And on the other hand, on the right-hand side, we understand that today development environments get more complex over time. You have tool sprawl, you have developers that are using different tools even within the same part of the business, multiple cloud environments, multiple deployment mechanisms, all are doing a great job in increasing the velocity of the development, but also introducing new difficulties for security teams to keep track of this ever-growing tooling area. Just another way to visualize this on a process and an architecture of an SDLC today, you can see how a normal life cycle of developing applications and building workloads in the cloud includes many steps, and in each and every step, there's different tools that do different security tools that help us assess the risk at that specific stage. So you can see here, for example, at the code side, right on the left-hand side, there's multiple tools that help us scan the code, whether it's for software composition analysis or static application testing. And then in the build phase, we have multiple detection tools doing a wonderful job at scanning our containers and our infrastructure as code and so on. And as the application development and the workflow advances across the software development lifecycle, there's more steps, more detection tools, and more complexities that come into place. And all of these tools are doing a wonderful job at helping us identify risk. However, this has become a huge number of data points, a lot of noise that comes into our system, and we need to find a way to better understand how to make sense out of all these detections, all this risk that comes out of our environment. So what we see here, and the reason that I wanted to talk about root cause with you all today, is that we understand there's an underlying context that is hiding behind all this data, all this noise, all this amount of signal that comes to security teams. So below the surface, there's a very important context that is missing for the security teams today. So the SDLC itself is, of course, it's very complex, but it has it's very well structured, and there's a lot of sense in the way that it operates. And so understanding this underlying context might help us address the security risks in a much more organized way, and in a way that would reduce the noise and make sure that we do the remediation in a smooth and easy way. So what you're seeing here is actually a very good depiction of this context that is missing. So in this example, we see that in a normal environment, we might have multiple detection tools here, and you see just a few, of course, examples of such detection tools alerting on multiple parts of our environment. In this case, we have two Docker images here that are being scanned by multiple tools that tell us that we have multiple issues and multiple risks in those images. And of course, without this underlying context, we would end up having tens or even hundreds of different alerts on those images. However, the underlying context, which is so crucial, is that those two images actually are built on top of a deeper image, on top of a base image. So base images in the world of containers is a common practice where code is being written once and then used multiple times. Code is being used in a modular fashion. And however, in many cases, this base image is what introduces a lot of the risk. And so this underlying context tells us that the base image is actually the origin. But even if we go further, then this base image is just an artifact that's being built from code. So if we go even further down the root cause chain, we see that the context that is missing is that this base image is built from a certain code file. And of course, the code file itself is being scanned by other scanning tools that find issues and vulnerabilities there as well. So this underlying context is tying everything together, but it's very hard to surface it in a useful and operationalized way for security teams. And so this is what we here at DAS try to solve around the root cause remediation. So what is root cause remediation? At the end of the day, it's the ability to expose this underlying context, this underlying SDLC context, in a way that becomes meaningful for security teams. So imagine that all of this context we just described is now at your usage and is now part of the context that you have when trying to address security risks. So all those different data points, all those different noise and signal and alerting that comes from all the different tools would now be tied together and mapped back to the root cause. So imagine like treating a sick person, right? That person might have multiple symptoms, might have multiple issues like fever and cough, and you can address each and every one of them separately. However, the root cause is that a disease that person has, and they need to get an antibiotic. So this is the concept of reducing the problems and the risks back to the root cause. And by that, you gain a lot of really good benefits for your remediation program. So for example, a very important benefit is that the backlog of remediation, which is usually huge, and usually security teams never get the time to actually go through this entire backlog. By reducing the amount of alerts back to the root causes, this backlog gets shortened dramatically, because instead of treating symptoms, you're treating root causes, and there's a lot less root causes than symptoms. So you end up reducing the noise and being able to address only what matters. Another very good benefit and a good approach when you take the root cause remediation approach is the ability to find and triage owners. So by reducing those symptoms back to the root cause, you are able to identify an individual, team, a part of the business that owns this root cause, and then that part of the business or that individual is then assigned to remediating that problem. So at the end of the day, by finding the root causes, you're also finding the person that is responsible for that piece of your environment, of your application, and they should be addressed in order to remediate the problem efficiently. Next very interesting benefit when you target root causes is that you can increase the ROI, the return on investment, of every remediation action that you take. So we all know development time is very precious, and we don't have time to spare. The developers don't spend most of their days remediating. So when we do get time to remediate things, we want to make sure that any time spent on remediating is done efficiently and effectively, and we remediate what matters most. So when you remediate root causes, you're actually fixing a lot of issues at once, because root causes actually generate many, many issues and many alerts, and those symptoms are the risks that you want to remediate. And if you remediate at the root cause, you're remediating a large portion of your risk in a very simple and efficient action. And finally, we see today that a lot of the problems in modern cloud environments is recurrence of issues. In many ways, if you just remediate the symptom, then the next time the workload is deployed, the next time the application is deployed, the symptom will just come back. Because if you haven't fixed the root cause, symptoms will just keep popping up again and again and again. For example, if you have some sort of workload that's exposed to the internet, if you just log into your cloud console and then shut that workload off from the internet, the next time a new deployment would run in modern cloud environments, it would just open it up back again. So fixing it, the root cause, actually prevents the recurrence of those issues. So I want to give you a few examples of what we mean when we talk about root cause remediation. So those are a few examples of what we call biggest bang for your buck remediation. So at the end of the day, we said that when you remediate the root cause, you're actually remediating a large portion of your risk all at once, which makes your remediation efforts much more efficient and much more impactful, and every time spent on remediating is a time well spent. So we have two examples here. On the top right, you can see an example in the world of container security. So this is very similar to the example we've seen before. In this case, it's an analysis from an environment we've worked on where we found a single base image. So again, base images in the container world are like a software package that can be used over and over again in a repetitive and modular way, which is a very common approach in modern cloud environments. So this single base image was actually responsible for almost 12,000 different high severity alerts. In this case, we worked with Prisma Compute, which is a common way to scan containers. So in this example, one base image was incorporated into 133 apps or applications, and those applications were spread across multiple parts of the environment, multiple cloud subscriptions, and at the end of the day, we're exposing 12,000 high container vulnerabilities, which incorporate a lot of risk to our organization. So without root cause remediation, we would have to chase those 133 different applications that have 12,000 different issues, and that would take us a lot of time finding all those 133 different apps, app owners, understanding where they originate from. And instead of that, taking the root cause remediation approach helps us triangulate and find this one single location that we need to address, which if we remediate there, we solve a huge chunk of the risk all at once. So instead of doing 133 different emails, different CVEs, different meetings, we can just address this one root cause location that usually is owned by a certain team that can just fix this and generate a huge impact on our risk reduction. Another example from the world of cloud misconfigurations is an example around infrastructure as code. On the bottom left, you're seeing an environment where DAS and the root cause remediation approach was able to identify Terraform, which is a very common way of deploying cloud resources with infrastructure as code. So root cause analysis was able to detect Terraform modules, which is another example of code blocks that are used over and over again in a modular fashion. So this concept is very common in modern cloud environments. And in the world of cloud misconfigurations, we're seeing here that those three modules, those three pieces of code that were used over and over, were deployed into almost 80 different cloud environments, in this case in Azure. So those 80 different cloud subscriptions were running different workloads, different applications, but the infrastructure in those workloads were all deployed using those same modules, those same fundamental pieces of code. And so those 80 different cloud environments were exposed to almost 1,200 high-risk issues, in this case detected by Wiz.io, another common cloud scanning tool. And so instead of chasing those 1,200 different high-risk issues one by one, trying to find the owner, find the relevant source, create a ticket, send an email, instead of doing all of that redundant work, if you take the approach of root cause remediation, you can just try and fix the issues at the core, where it matters most, which is at the Terraform module in this case. So if you fix the Terraform modules by doing just 3 simple code fixes, you can then affect 80 different cloud environments and reduce a large substantial amount of the risk all at once. So those are 2 examples. Of course, there's many, many more of why remediating at the root cause gives you a huge impact and large ROI in terms of reducing risk in your environment. Another very interesting benefit that you gain from taking the approach of root cause remediation is the ability to identify ownership all across your software development lifecycle. And I think there's 2 very interesting quotes here that you see from teams that try to remediate in the cloud in real live environments, real live organizations. And you see how much of the effort is spent on identifying owners. One VP of cloud security says that 80% of the time needed to remediate risks goes to finding the owner. And so this part of finding the owner is such a substantial part of remediating risk. And by finding root causes, you can actually automatically identify those owners. So by going back to the root cause, you understand who is the person that deployed this workload, who is the person that has written the code or the configuration or has done the deployment in any way that created the risk in the cloud. So you now have a very good lead on what is the team what is the business unit, what is the part of the business that owns this risk and should be addressed when trying to remediate that. And so, of course, performing the root cause is the initial step of finding the ownership, and you can then incorporate on top of that a lot more business context in order to generate the ownership needed for every part of your software development lifecycle and cloud workloads. So just a little bit about how does it work? How do you do root cause remediation from a technological standpoint? So at the end of the day, there's a lot of context and there's a lot of logic in how SDLCs work. So if you take all the data points and all the metadata from the different steps in those parts of the SDLC, then we've built an engine that actually is able to tie all those metadata points together in order to generate this root cause context and perform what we call the root cause analysis. So our engine that performs this root cause analysis connects using API to key points and key parts of this SDLC process. So analyze the metadata from the code repositories, from the source code management tools. Also analyze the metadata from the cloud providers themselves, from AWS, Azure, GCP, and so on. And then, of course, analyze the metadata from anything in between, whether it's CI/CD pipelines, CI/CD logs, whether it's any infrastructure as code artifacts, container artifacts, software artifacts, and so on and so forth. And by analyzing this large data, this very big data that comes from all these different key points in the SDLC, it is possible to tie together the points in order to build this flow and connect the different dots in a way that makes this root cause analysis process possible. And so behind the scenes, we've built an elaborate engine that uses a few patterns that enable this metadata connection. But once we have this root cause analysis laid out and this discovery of the pipeline is performed behind the scenes, then we can start utilizing this context in order to remediate our cloud risk in an efficient way, as we've seen before. So I'm going to stop here and see if there's any questions that come from anyone. And I was happy to share with you all about root cause remediation and the benefits and how it's done in real life environments. Thanks, everyone.
Going back, thank you for that presentation. It was great, and thank you everyone who's on the line. We have a couple questions for you really quickly. The first one is, my biggest challenge is to get developers to actually fix stuff. How do you communicate this to developers?
Yeah, thanks, Alex. So I agree that's a big challenge. I think, you know, as security persons and personnel and security teams, we have the responsibility to reduce the risk and remediate the risk, but in many cases we need the time of the developers to actually perform the remediation. And so I think a very big thing around root cause remediation is that it generates a context that's very useful for developers, that's very friendly for developers. And so using this context, you actually bridge the gap, you know, to communicate with those developers and get them more on board in remediating risks. And so, of course, you know, you can take the context of the root cause that is shown here and then push it out to developers, whether it's via ticketing or pull requests, or even we've seen success with developers logging in and getting the context on their own using self-service approaches. So I think it's a really good question, and one of the big things we're trying to do is bridge the gap between the security teams and the developers and make sure that everyone's on board and everyone's doing the best effort they can into remediating the risk.
Great, thank you for answering that. One more question for you. I use a lot of third-party tools in development in my environment. How would that work?
Yeah, that's also a good question. So a lot of the examples that we've seen were about workloads that are internally developed, you know, by developers that are first party, that are part of the organization. But in modern environments, like you say, there's a lot of third-party usage of just full workloads that are run in our cloud that just come from third-party vendors. And so I think it's a big challenge. And one of the things is that when you do root cause remediation and root cause analysis, then you can automatically identify those third-party workloads and actually flag all the risk that comes from those third-party workloads in a very easy way for you to identify what is first-party, what is third-party. And then when you understand what is coming from third-party developers, whether it's contractors or whether it's actual third-party you just run in your environment, then you can start a more efficient remediation process that doesn't waste the time of your own developers in chasing risks that come from third-party tools. So this is a big challenge, and I think taking the root cause remediation approach can definitely help address that as well.
Great, that's all the questions. Thank you.
Great. All right. So I was super happy to be with you all today, talk about root cause remediation, share some of the knowledge on this wonderful Wednesday Wisdom session, and hope to see you on the next sessions.